Hello, my dear students. Today we will discuss basic concepts of function and understanding the foundation of function. Okay, here's a what is a function. First of all, we have to understand what is a function. A function is a special mathematical relationship between two sets where each input has exactly one output. Okay, and for formal definition, it's a let A and B, two non-empty sets of real numbers. If there exists a relationship, if function says that for every x element of A, there is exactly one y element of B, then f is a function from A to B. As you can see here, y is equals to function of x, and x is element of A. Okay, like you can imagine a juice machine. When you import some mangoes in a juice machine, you will get juice from this machine. So yeah, it's also kind of a function, right? Let's move our next slide. Here's some key terminology of about function. It's an independent variable x and dependent variable y. What is independent variable? The input value that we choose freely from the domain, and dependent variable the output value that depends on x. And domain is expressed df, d sub f, the set of all possible input values. Okay, it's a d sub f is equals to a, and range r sub f. Okay, the set of all possible output values. It's a r sub f is equals to, is a f of x, absolute value is a x element of A, and which is also subset of B. Important rule: one input cannot give two different outputs. However, the same output can come from the different inputs. Okay, so let's move our next slide. Yeah, understanding functions input and output mapping. Okay, a function establishes clear relationship where each input from its domain is precisely mapped to one output in its range. This visual diagram illustrates the core principle of how functions transform values. Like here's a domain A is all values of x are domain, and here's a function, and all values of y is a are the range. Okay, yeah. So the fundamental rule for any function is that each input must correspond to exactly one output, while different inputs can sometimes lead to the same output. A single input can never yield multiple different outputs. Yeah, here's an MCQ for you. Understanding functions. Which of the following represents a function? First one is each person's name corresponds to their phone number. Yeah, it can't be function. And here's a B. Each student's ID corresponds to their exam scores. They may have multiple scores. It's nonsense. So it can't be also a function, represent a function. Each number squared gives is its square. Yeah, this is the function. And here's also D. Each month corresponds to the days in that month. No, it's also not function. So it's not function. It's not also function. So this one is the right one. Okay. Yeah. Here's also correct answer C. Yeah. For each number x squared is exactly one number. Option A. A person might have multiple phone numbers. Option B. It's a multiple exam scores means not exactly one output. D. And February can have 28 or 29 days. Yeah. It's a now finding the domain. the domain of a function includes all real numbers except those that cause problems. Okay, now problem 1 is a division by 0. Here's a for 1 divided by ace of x, solve ace of x not equal 0. This, yeah. And problem 2 is a even roots of negative numbers for root g of x, and solution will be a g of x is a greater than equal 0. And here's a problem 3, logarithms of non-positive numbers for log g of x, solve is a g of x greater than 0. And here's also finding domain for f of x, root over x plus 1 divided by x minus 2. Here's a take the square root. Okay, first of all, here is an root over x plus 1 needs x plus 1 less greater than equal 0, so therefore x greater than equal minus 1. And here is a fraction, 1 divided by minus 2 needs x minus 2 not equal 0, therefore is a x not equal 2 also. So combine coordinations, here's x greater than equal minus 1 and x not equal 2. So domain is a, here's a set is x less than x greater than equal minus 1 and x not equal 2. And interval notation, it's a minus 1 2, here's a close bracket and open bracket, and union is a open bracket to infinity open bracket. Okay. It's a domain problem. Yeah, here's a domain problem, MCQ 2. It's a what is the domain of f of x equals to x square minus root over x square minus 4 plus 1 divided by x minus 1. Okay, here is A, option A. Is x is greater than equal to or x is less than equal minus 2? Yeah, this is not possible, right? And x greater than equal to or x is less than equal minus 2 and x not equal 1. Yeah, it's right. And all real numbers except x equal 1, no. Dx less x greater than 1, it's also no. Yeah. Root over x square minus 4 requires x square minus 4 less than equal 0 and x minus 2 and x plus 2 into x plus 2 greater than equal 0 and x less than equal minus 2 or x greater than equal 2. Here 1 divided by x minus 1 requires x not equal 1. So combine, if we combine it, x less than equal minus 2 or x greater than equal 2 and x not equal 1. Function evaluation. To find f of a, substitute x minus a into the function's expressions and simplify. Example is here for f of x is equals to root over x plus 1 plus 1 divided by x minus 2. If you calculate f of 3, it's very easy, right? You have to just replace x by 3. So root over 3 plus 1 here, as you can see, is a 3, and f of 8 is the same as before. So what is the answer? It's a 19 divided by 6. And what is the common mistake students can do? Always check if a is in the domain before evaluating. So MCQ 3 is a function's values. If f of x is equals to 2x squared minus 3x plus 1, and what is the f of minus 2? So we have to calculate this one. If we input the x is minus 2 minus 2. What will be the answer? Is a minus 2, that means a positive. It's a 4, right? It's a 4 into 2, it's 8 minus 8 plus 6 plus 1. What will be the answer? Answer will be the 15, this one. Okay, if you calculate here, 2x square minus 3x plus 1, so 2 into minus 2 square minus 3 into minus 2 plus 1, so it will be the 8 minus positive 6, cause of here is a minus, here is a minus also, so minus minus plus, and plus 1, so it's a 14 and it's 115, right? Yeah. So equal functions, two functions f and z are equal if and only if same domain, same range, and same rule. Condition 1, it is same domain. Both functions must have identical input sets. And condition 2, both functions must have identical output sets. And same rules is f of x equals g of x for all x in domain. All three conditions must be satisfied for equal function. And here's also examples of function equality. Is y equals to root over x squared the same as y equals to x? Is what? Okay, so for y and equal x, domain r, range r, what will be the answer? We have to find out these things. So domain, here you can see r, and range is a 0 to infinity. Okay, and here is also x is the absolute value. Is these are equal function? I think it's not equal, right? Okay, domain are equal, but range not the same. As you can see here, is y equals to, yeah, is a x cube the same as y is equals x? It will be, is this correct? Is this equal? So x for the all real number x and same domain r, same range r, same rule, so it's equal. And function equality, which functions is identical to f of x is equal x? Which one is identical function? Which one is which function is equal? Is this equal? Yeah, it's not right. H of x is a root over x whole squares. No. Is a k of x is a root over x square. No. And m, yeah, this one is correct, but why this one correct? Let me check. For all real number x, yeah, this one is identical, that's why this one is correct. And part 5, graphing functions. The graph of a functions y equal f of x is the set of all points x comma f of x plotted in the coordinate plane. It's a linear function, y is equals to 2x, and this one is linear function. Okay, and if you this is a straight line through the origin, like, yeah, it will be straight line through the origin. This one is origin O, this one is x, this one is y. if you put yeah, x and y, when x equals 0, y equals 0 0.00, okay, and when x equal 1, there is y equal twice x. When x equal 1, 2 into 1, it will be the 2, yeah, 2. That means this, the point is 1 2 2 4 for the 2. As you can see here, graph of y equals to twice x. Yeah, this is the graph. It is a straight line through the passing the origin. And absolute value function. The absolute value function y is equals to absolute x is defined as like y equals to absolute value of x is equals to x. So x minus x if x greater than equals 0 and if x less than 0. For x greater than equal 0, graph is y equal x line with slope 1. Okay, and for x less than 0, graph is y equal minus x line with slope minus 1. Key points are there: minus 2 2, minus 1 1, minus 1 1 0 0 2. Notice here all the value of these all values are positive. There's a graph of y is equals to x. Yeah, you can see here y is equals to absolute value of x. The graph forms a V shape with vertex at the origin 0 0. Yeah. Graph shape. What is the correct graph shape for y is equal to x? Straight line, parabola opening upward, a V shape with vertex of at origin. Yeah, this one, right? And we see it before. Yeah, it's a V shape vertex at origin. It's a set Wheeler notations here. It's a x greater than equal minus 1 and x not equal to means all x such that x greater than equal minus 1 and x not equal to. Yeah, this one and this one. Okay, here's a function of x, all function of x values where x element a, that means x comes from set A. Common mistakes: confusing domain and range. Domain equal input values and range equal output values. Domain is the input values and range is output values. Remember that. Remember this one. Okay. Here's also examples of finding range. So f of x is equals to 2x squared minus 1 with x element of the minus 2 1 2 3. Okay, and we have to calculate all the functions values is for minus 2. For first one minus 2, if you replace the x by minus 2, we'll get the value 7, and if we replace the x by 1, we'll get 1. For 2 we'll get 7, and for 3 we'll get 17. Okay, that means range are 1 7 17. So notice here here is a f of x, right? F of x is equals to 2x square minus 1. Yeah, so these are the range. And what will be the domain? These are the domain: -2, 1, 2, 3. These all are the domain and these all are the range. Okay, here's a MCQ 6 range questions. For f of x equals to 2x squared minus 1 with x element of -2, 1, 2, 3. And what is the range also? Yeah, we calculated before. It will be the 1, 7 and 17, right? Yeah, it's a complex domain here. F of x is a root over x minus 3 divided by x squared minus 4. What is its domain? So we also solve it before. Its answer C is a x less than equal 3, sorry, greater than equal 3 and x not equal 2. Yeah. A summary and key points is a function definition. Each input exactly one output. Their parts: domain, range, role, and domain roles. No division by zero, no even roots of negatives. Always verify restrictions. And function quality: same domains, the same range, and same rule. All three must match for function equality. And graphing basics: it's a plot points, it's a x, f of x, and connect appropriately B shape for x. And the common student errors: forgetting to exclude values that makes denominator 0, and forgetting that root over expressions requires expression less than equals 0, and confusing domain is a inputs with range outputs, and thinking is a y equals to root over x square equals to y equal x. It equals absolute value of x. It's instead. It's a practice questions. The following 5 questions will test your understanding, but chapter 3.2 concept, try to solve them without a calculator. Okay, here's a practice problem for you. Now you have to solve this. Take a screenshot or pause the video. You can solve it. Okay, and here is another one, and here is the answer. Sorry, here is the question 5. Yeah, there's the answers. Okay, yeah, you can take a screenshot or pause the video. Okay.